This is RD Sharma Solutions, Class 11 Maths, Chapter 1, Sets, Exercise 1.2. So we have to describe these sets in roster form. So they are right now in set builder form. First is X is such that X is a letter before E in the English alphabet. So if we start with A till Z and somewhere we have E in between. So X is a letter before E in the English alphabet. What will be the answer? See, I start with A, B, C, D, E. So all the alphabet before E are A to D. So the answer will be simply this one. A, B, C and D under curly braces. Next is X. This question is X belongs to capital N such that X square is less than 25. So you have to take this N is standing for the natural number, and we know natural number starts from 1 until infinity. So 1, 2, 3 like this. These are the natural numbers. So this is the natural number and there is no restriction, so it has to start from 1. And this, whenever we do the square, it has to be less than 25. That is 1 square, 2 square, 3 square, 4 square, 5 square. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16 and 5 square is 25. So this number 25 is not less than 25. 25 is actually is equal to 25. So it will not include 25, that is will not include 5. So the answer only will be 1, 2, 3, 4. 1, 2, 3 and 4. Next is the question here is X belongs to, this is X belongs to N, X equal to 2N, X belong to N and X is a prime number, sorry this one. X belongs to N, X is a prime number and X is between 10 and 20. So we have to find the numbers between 10 and 20 which are prime. So we have 11, then 12, 13, 14, 15, 16, 17 and 18, 19. So these are the number between 10 and 20. Between 10 and 20, these are the numbers. The next one is X belongs to N and X equal to 2N, and this one is saying N belongs to capital N. So N also belongs to this X and N, they both belongs to natural number, and X is equal to 2N. So we have to simply, this is 1, 2, 3, 4, we have to put here in this place. So it's simply the table of 2. It is simply the table of 2 and there is no restriction also. So you have to start with 2, 4, 6, 8 and just, after writing say 4 or 5 numbers, just write these 3 points, 3 dots. These 3 dots, 2, 4, 6, 8 like this. These 3 dots shows that it is going to infinite. Next is X belongs to R and X is greater than X. So X is greater than X and X belongs to the real number. But if you see, you take any number, say 2. Is 2 greater than 2? No. Is 3 greater than 3 or I say 1.2 greater than 1.2? No. So we have nothing here. So it's 5. The set is, we have an empty set. So this is 5. Actually, it's not a set. It's actually empty. There is nothing going to come 5. Then next is X is a prime number which is divisor of 60. So 60 is divided by what? Let us start with 1. 1, 2. 2 is the first prime number. Then 60. Then we have 3. Then we have 65. Then we have 7. So 7 doesn't divide. And these are the 3 numbers. These are the prime number which are divisor of 60. So 2, 3, 5. These are 2. It divides truly. So 2 30s are, 3 20s are, 5 12s are like this. So we have 2, 3, 5 as the answer. 2, 3, 5. Next is X is such that X is a 2-digit number such that the sum of digits is 8. X is such that X is a 2-digit number such that sum of digits is 8. So you take any number, say 2 and 6. it adds up to 8, and 6 and 2 also adds up to 8, like 2 plus 6 and 6 plus 2. So what we have done, 1 and 7 and 7 and 1, 2 and 6 and 6 and 2, 3 and 5 and 5 and 3, and of course 4 and 4 adds up. Then we have 8 and 0 also. If you plus 8 and 0, it will be 8. But if you take 0 and 8, 0 and 8 will not be a 2-digit number. 8 is not a 2-digit number. 80 is a 2-digit number. So you don't include 0, 8. That is why you just have 80, not 08. So these are the numbers which adds up to 8. Next is the set of all letters in the word trigonometry. So trigonometry, if you take, see, this O is repeating, so we'll take just one O. Then we have R repeating, so we'll just take one R. We have T repeating, so we'll take one T. So we have T, R, I, G, O, and M, E, Y. All these with only one of the repeated ones, that is T, R, and O. Then the set of all letters in the word better. So I'll just take again B-E-T-T-E-R. So B I'll take, E is twice, so I'll take E as 1. Then T is twice, we take T as 1, and R as 1. So B-E-T-R. This is the set. Now here we have to do just the reverse. That is, we have to describe these sets in set builder form, and this is given in the roster form. So A equal to 1, 2, 3, 4, 5, 6. What are we going to do? A equal to 1, 2, 3, 4, 5, 6. So these are simply the natural numbers, but there is a restriction. The natural number is there, but there is a restriction that these numbers are less than 7. So how do we write this? X is such that X belongs to capital N, that is X belongs to the natural number, and X is less than 7. See, we start with 1, it is a natural number. The natural number starts with 1 only. Then it goes up to 6, and we don't jump after 6 because it is less than 7. This is how we write it. Next one is 1, 1 by 2, 1 by 3, 1 by 4. So all these, 1 by 5 till. So all the numerator is 1. So what we have to do is 1. And this 1 by 1, 1 by 2. So 1, 2, 3, 4 in the denominator, they are nothing but the natural numbers. So let us write 1 by n. So what we are going to write, X is such that X equal to 1 by n, where n is a natural number, n belongs to a natural number. Then third one is 0, 3, 6, 9, 12. So this is a table of 3, but we have to start from 0. So actually if I write X equal to 3k, and k belongs to z plus. What is z plus? Z plus is the integer. Integers are what? Like 0, 1, 2, 3 to infinite, and minus 1, minus 2, minus 3, like these are the integers. So if I take this one, that is I have to take this side. So we start with z. We will say not z but z plus, because z minus would be this one, this side. So z plus we are taking this side. So z plus, so k belongs to z plus, and z equal to 3k. So we start with 0. So 3 into 0 is 0. 3 into 1. Now 3 into 1 is 3. 3 into 2 is 6, like this. So X is such that X equal to 3k, and k belongs to z plus. This is a set of positive integers. Next is 10 to 15. So we just have to give the restriction because we know that these are natural numbers. So we just say X belongs to n. X belongs to n, but there is a restriction in X, that is it is greater than 9 and it is less than 16. It is greater than, because after 9 comes 10. 10, 11, 12, 13, 14, 15, and then below this we have 16. So we will write here as X belongs to n, and then we have X is between 9 and 16. E equal to 0, and this is a set. So 0 can be, if you take integer, 0, 1, 2, minus 1, minus 2, these are the integers. So if we say an integer between minus 1 and 1, so if I say X belongs to Z and X is between minus 1 and 1, it will be 0 only. Or you can directly put it as 0. So you can just write X belongs to Z and X equal to 0. This is also valid. This is also valid answer. 1, 4, 9, 16 till 100. And if you see closely, these are all the squares. 1 square is 1, 2 square is 4, 3 square is 9, and 4 square is 16, like this. So it goes up to 10 square. So these are 1 to 10 natural numbers. 1 to 10 natural numbers. Okay? These are nothing but 1 to 10 natural numbers. So what we are going to do, and these are squares also. These are square. So we have x square. This x is a natural number. X belongs to a natural number. And we have to restrict it from 1 to 10 because it is going from 1 to 10 only. So x is between 1 and 10. It is equal to 1. See, it has 1 and it is 10. So it is greater than or equal to 1 and less than or equal to 10. So this is the set. 2, 4, 6, 8. So this is simply the table of 2. So we'll just write x is such that x equal to 2n. 2n. And we have to put 1, 2, 3, 4 in this n. So n belong to capital N. That is the natural number. You know, natural number are from 1 to infinite. So this is just simply a table of 2. Here, this is 5. This is 5 square. 5, 3, 5 to the power 4, like this. So we'll just write 5 to the power n such that this n belongs to, because this is 1, 2, 3, 4 and these are natural numbers. So n belongs to n, but we have to restrict this natural numbers from 1 to 4 because there are only 4 numbers. So what we'll do, this n is greater than or equal to 1 and less than or equal to 4. This is the answer. Next is list the elements of the following sets. And what is the first set? The first set is given like this. A is equal to x such that x square is less than, I'll just go and take this one. This is the, so the question here is, we have to say that A equal to x square less than or equal to 10, and this x belongs to z, that is, it is belonging to the integer. So when it is an integer and x square is less than or equal to 10, so if you take integer 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4 till here. So if you see that if I take 0 square, it will be 0, 1 square is 1, 2 square is 2, 3 square is 9. So it is below 10. We have to very seriously see that it has to be below 10. 1 square is 1, 2 square is 4, 3 square is 9, 4 4s are 16. So we can't take this. So our set is only this much. So we'll just write either this whole set you can write like this. This is the answer. Or you can just combine these two. You start with 0. This minus 1 and plus 1 can be combined as plus minus 1. This minus 2 and plus 2 can be combined as plus minus 2. Minus 3 and plus 3 can be combined as plus minus 3. This is the answer. The next one, the question here is B is equal to x such that x equal to 1 by 2n minus 1. 1 by 2n minus 1. And there is a restriction on this n. It is between 1 and 5. So it is between 1 and 5. 1 and 5 are inclusive. So what you have to do, just put n equal to 1 till 5. That is x equal to 1 by 2 into 1 minus 1. I am putting 1 to 5. Next will be 1 by 2 into 2 minus 1. Then will be 2 into 3 minus 1. Then we have 1 by 2 into 4 minus 1. And then we have 1 by 2 into 5 minus 1, like this. So 1 by 2 minus 1 is 1 by 1. It is 1. 1 by 2 to the 4. 4 minus 1 is 1 by 3. And we have 1 by 3 to the 6. 6 minus 1 is 1 by 5. And then 1 by 4 to the 8 minus 1 is 1 by 7. And then we have 1 by 5 to the 10. 10 minus 1 is 1 by 9. So we have 1 by 3, 1 by 5, 1 by 7, 1 by 9. So this is the set. Next is question number 3. The part is third. So third is, the question here is C is such that C is equal to X is such that X is an integer. This is the question. And minus half, X is between minus half and 9 by 2. So X is between minus half and 9 by 2. That means minus half is what? Minus 0.5. And what is 9 by 2? It is 4.5. So we have to find an integer between them. Right? After minus 0.5, what comes? It is 0. Then we have 1, 2, 3 and then 4.5. So this is the set. we have to find out the integers. So 0, 1, 3, 4 are the integers. Then we have this question, which is A, I, O, U. What is this? X is such that X is a vowel in the word equation. So this is the question actually. So equation, what all vowel we have? Equation. So A, E, I, O, U are the vowel. So we have E, we have U, we have A, we have I, and we have O. So all of these are there. A, E, I, O, U. Next is X is such that X is a month of a year not having 31 days. The question is the month not having 31 days. So all the month from January to the December, if you see, they may contain 28 or 29, it goes for February. Then we have 30 or 31 days. So those which are having 31 days are January, March, May, July, August, October, December. Just subtract this from January to December. So we get February, April, June, September, November, which are not having 31 days. So this is the list. Then X is a letter. X is a letter. The question is, X is a letter of the word Mississippi. This word. The question is, X is such that F equal to X is such that X is a letter of the word Mississippi. So in Mississippi, M is 1. So we write M. I is thrice 1 or 4 times. So we write 1 I. S is 1, 2, 3, 4. Again 4 times. And P is 2 times. So we write P. M-I-S-P. This is the one. Now we have to match each of the sets on the left in the roster form with the same set on the right described in the set builder form. So this we have on the left hand side APLE. And if you see on the right hand side, the sixth one has X is such that X is a letter of the word apple. So this will match with X is a letter of the word apple. Second is 5 and minus 5. 5 and minus 5 we have to match. On the right hand side, if you see this fifth one, this is matching, right? So we have X is such that X square minus 25. So X square minus 25 equal to 0. That means X square equal to 25. So X will be equal to plus minus under root 25. This will be equal to plus minus 5. Next is the set is 0. On the right hand side, if you see the first one, is it is saying X plus 5 equal to 5. So X plus 5 equal to 5 means X equal to 5 minus 5, that is X equal to 0. So this we match with the first one. If you take the fourth one, which is 1, 2, 5, 10. 1, 2, 5, 10. So if you see on the right hand side, we get X is a natural number and divisor of 10. X is a natural number and divisor of 10, which is the fourth one. So we have a natural number and divisor of 10. So 1, 2, 5, 10, all these numbers, they are actually dividing 10 and they are natural numbers also. So we go with the fourth one. Then the fifth one, the distinct letter of word Rajasthan are. So A-H-J-R-S-T-N, and we match it with what? This is the fifth one. So on the right hand side, we have Rajasthan. X is such that X is a letter of the word Rajasthan. So these are all the letters of word Rajasthan. So we match it with this one, which is the third one. Third one on the right hand side of matching. So 1, 2, only 2 is remaining. So we know that this is going to be 2. So second one will be, and the 2 and 5 is on the left hand side, and the right hand side we have X is a prime number, a prime natural number, and is the divisor of 10. So 2 and 5, these are actually dividing the 10, and they are prime natural numbers also. The next one is, the question is, write the set of all vowels in the English alphabet which precedes Q. So I'll just start with A, B, C, D, E, F, G, H, I, J. So we have to go up to Q. Only up to Q. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. So we have to go up to Q. R, S, T, U, V, W, X, Y, Z. So we have A, E, I, O. They all are the vowels coming before Q. Means this is the set because here is Q. Only U is coming afterwards. So A, E, I, O, U will be the answer. This is the answer. A, E, I, O. No U. Only U is coming after this Q. So the answer will be A, E, I, O. No U. Okay. The question next one is, write the set of all positive integers whose cube is odd. Find the set of all positive integers whose cube is odd. So we know that cube of odd number is always odd. If you take 3 cube or 1 cube is 1 always. 3 cube is 3 is 9, 9 is 27. You can do it with 5 also. 5 cube. 5 5 is 25. 25 into 5 is 125. All these are odd. So what we have to do, x belongs to z. That is, we have to take the z, which is the integer, and we just say x equal to 2n plus 1, right? And n is greater than or equal to 0. This is the set. This is the answer. Next is write the set 1 by 2. 1 by 2. The set is like this. Let me write you the question first. So we have to write the set 1 by 2, 2 by 5, 3 by 10, 4 by 17, and this goes up to 7 by 50. So if you see the numerator, if you observe numerator, these are 1 to 7. So 1 to 7 is the restriction. So we have to just give the restriction from 1 to 7, which is the numerator. So let us say it is n. So the numerator will be n. And what is the denominator? 2 comes when I write, this 2 comes when I write 1 square plus 1. So 1 square plus 1 is what? 2. How does this 5 comes? 2 square plus 1. 4 square plus 1 is 5. So 10 comes with 3 square plus 1. So 3 square is 9. 9 plus 1 is 10. So do we get n square plus 1? N by n square plus 1. So what the set will be? N by n square n plus 1, such that n belongs to capital N, which is the natural number. And this small n has a restriction. It has to be between 1 and 7 because it is from 1 to 7. So this is the answer. So this is the exercise 1.2 of R.D. Sharma class 11. Thank you so much. Take care of yourself.